All right, so this one we have high-speed internet. And so it says this table down here gives us a number of homes in the US eligible for high-speed internet connection. Explain why a log model might be appropriate for the data. And we want to do that, we have to actually plot the data. And I'm going to look at part B so I don't have to plot the data twice, but it says 2003 is going to be 0.5, 2004 is 1.5, and so it looks like we're going to go up like that. And so I'm going to plot these versus this. And so let's go to our calculator. And I've already typed them in to save that time. And so this is what our graph looks like. Now, why is it log, they ask, okay? Well, if you look at that, it kind of looks like it's kind of going up, but it doesn't look like it's going back down. Kind of looks like it's sort of getting higher a little bit and a little higher. Kind of depends on how you draw your line, but it's going up slowly and it's not, drastically increasing. We have it, it's concave down, so that's a good thing. So yeah, I think I would call that, a possible log. Now, the question is it a log? So let's go ahead and do our calculation. And so we need a 9. Let's go ahead and plug that equation into var1. And so that's the equation I need. So 100.527 and then 11.912 ln of t. All right, so that's what it looks like. And now this makes it look much more like a log plot than just looking at those dots, because they were hard to see. But if you look at that, it has a sharp come up and then kind of coming over, so that it does look like it fits that log plot there. All right, so let's go back and do our work over here and write what we need to do. I'm not going to explain part A. We kind of did that by that, but let's do B and write our log model. So that was f of t, or f of x rather, I'm going to use, because it's supposed to be t for time, I think, but they said, have x here, so I'm going to use x, is equal to, it was 100.527. Why isn't it writing? Okay, and then we had plus 11.912 ln of x. Okay, so that was our log function. Now we need to write a model for the rate of change of the number of homes eligible for that. So that means we have to take the derivative. Okay, so f prime of x equals, well, if we do that, that goes to 0 and we take the derivative. This we're going to have 11.912. Now when we take the derivative of ln of x, remember that goes to 1 over x. And so I'm just going to write this 11.912 over x. Now, what do we have? It's million homes, and it's going to be per year. And that's going to be our rate of change for the number of homes eligible for high-speed internet. So I'm not going to write all that, but that's going to be my model I use for the rate of change. Now, D asks for calculate the number of homes, the rate of the change of homes, and the percent rate of change of homes in 2005 and 2010, and then interpret the results in context. Okay, so we've got multiple items we have to do here. Okay, so number of homes. Okay, well, f of number of homes, that's just going to be f of the number, and this is since 2003, and we want it in 2005, so that would be a 2. Yep, but that's 0.5, so that's actually 2.5. I gotta look in because we have to reuse the same units there. So luckily I wrote that there and I remembered it. So that's gonna be 2.5 in 2005. And so now we just have to plug those values into our function here. And so we have 100.527 plus 11.912 ln of 2.5, and that gives us 111.442 Okay, and that's going to be million homes. Now we also need to calculate the rate of change, so that's going to be our f prime of 2.5. And so that's going to be 11.912 divided by 2.5, and that's going to give us 4.765 if we go to 3 decimal places. What did I put 11 for? Okay. And then the last one it wants is the percent rate of change. So that would be the percent rock. And remember, that's just going to be our f prime divided by our f. And so we'll have 4.765 divided by 111.442, and then times our 100%. And so if we take that and divide that by 111.4, that and times 100, we get roughly 4.28%. Or, if we round it down to even one decimal place, that's 4.3%. Okay, because we have, only one decimal here, so I would say maybe that might be a logical thing to do, 4.3%. Now, to write all that out, let's see here. So we would say in 2005. Now let's write it out as numbers instead of saying million homes or something like that. So we would say 111,442,000 because we're going to multiply that by a million. So we're going to have move over 6 decimal places that way. So we'd have 111,442,000 homes in the US were eligible for high-speed internet connection, and the number of homes was, and now what was it doing? It was increasing by 4.765 million homes. So again, I'm going to write that out, was increasing by 4 point, what was it again? 4.765000 homes per year, or we could, since we have to also do that last number, 4.3%, or increasing by 4.3% per year. Okay, so all three of the numbers we had to get into here, and so I just made it a super long value here. All right. I'm going to skip number 2010 because it's going to do the same thing, except we just plug in our values for, the value what 10 is. So 8 is going to be that, and 9, 2009 is going to be 6.5, 2010 will be 7.5. So we're going to find f of 7.5. We're going to find f prime of 7.5, and then we're going to find the percent rock at 7.5, and then we're going to write the exact kind of same sentence there. So we just have to do those calculations, and that would give us the next one. But again, we know how to do the calculations. We just plug in our numbers into those two equations, we get them out, and then after that, we just have to state a long thing, in 2010, blah, 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 homes in the US were eligible for high-speed internet connection, and the number of homes was increasing or decreasing, we don't know at this point, by that many homes per year, or increasing by or decreasing by some percent. Okay, and so we would do all those calculations and get that. But again, I'm just going to do the 2005. All right, so that's all I have for this section.